Welcome to the lecture series on soft computing in computer science. This is the second lecture in the topic fuzzy set and its operation. So in the previous lecture we have discussed and we have ended with the discussion with fuzzy versus probability. When I want to create fuzzy set, I need to do two things. One is, first I should identify the set of, that means universe of discourse. Second, I need to identify a suitable membership function to quantify the degrees of values. So these are the two things you need to think about before construction of fuzzy set. You should keep in mind that membership function is subjective in nature. Why? Because it is already discussed with a variety of examples that membership functions should be specified for the concept and the values may be different with respect to different persons. So overall what is being conveyed with respect to fuzzy versus probability is subjectivity and non-randomness versus objectivity and randomness. In probability all experiments are random experiments and the outcome of all random experiments are objective based, whereas in fuzzy logic all experiments are non-random in nature as well as the answer or solution for each experiments are subjective nature. So that is the major difference between fuzzy as well as probability theory, fuzzy set theory versus probability set theory, right. Again I wish to illustrate the difference between the fuzzy or the idea behind the fuzzy with a lot more examples. Let us take an example, classification of set of days in a week, right. So first if you look at the picture, I have lot of words: shoe polish, butter, liberty, dorsal fins. Now if I ask someone to identify set of days of a week from the available list of words, so definitely what do you want? I took Monday, Thursday, Saturday, because these are the three words that are very different from the words shoe polish, butter, liberty, dorsal fins, right. So this is very easier, this is very easier because what kind of treatment is here? The treatment is objective treatment. For every person, if you call him and ask him, you please identify the set of days of a week from the available set of words. What are the words are there? You have given 1, 2, 3, 4, 5, 6, 7, total 7 words are given, out of which the person has to identify which are the words that belongs to days of a week, right. So that is the idea. But consider the second example, set of days of weekend. So in this case, see, there is a small gap, right. Sometimes for some persons Friday afternoon onwards weekend start, they have a plan for weekend celebrations or weekend plan or weekend trip like that and all. But some people only the Saturday morning the weekend starts, right, or Friday night the weekend starts. So this is the case when you want to say, for example, say, see, look at the question here, is Saturday a weekend day? Yes or true? Yes. Is Tuesday a weekend day? No. So we may say, see, is Friday a weekend day? This is an unambiguous one. Majority they say that yes, but not completely. So it is quantified as 0.8. Likewise, is Sunday a weekend day? Yes, of course, for majority 9.5. But when Sunday afternoon crosses, most of them feel like no, tomorrow Monday we need to do this job, we need to do these jobs. So the planning will go like that, planning will go. So overall what I mean to say from this example is subjective phenomena. Subjective. Person to person it differs. Suppose if Monday is a holiday, maybe for some government holiday or maybe some occasion holidays, then Sunday is also treated as a weekend, complete weekend day, otherwise it won't be. So some partial truth is available, right, presence. So when you look at this in a pictorial form, see, when you apply two valued logic, that is bilateral logic, Thursday is not a weekend day, Friday is not a weekend day, but Saturday and Sunday fully treated as weekend. But when you take this case, see, there is a gradual thing. Thursday afternoon onwards we start thinking about Friday, like that, like that, like that. Of course this is the natural scenario, right? So you, what you we said, there is a smooth transition, there is a smooth transition, not a sharp cut. So this is the another way of illustrating the idea of physiology. Likewise, when you want to classify the season, summer season, winter season and all won't happen in the midnight. So until today midnight you are experienced with the hot season. After 12:01 you will be experienced with the winter season. If that is not so, even the nature is not allowing that. Nature is not allowing the crisp or very sharp decision. Even the nature is allowing the smooth transition, right? Summer is going and it enters the peak and it is start gradually decreasing and enters into this another season. Likewise, winter is starting and winter is going to the peak value and then it is coming down with a gradual way and going to the another season. So even the nature is also not doing the any task in an objective way and is also doing the subjective way of having the smooth transition from one season to another season. So this is what the another idea that make you to understand about the subjectivity as well as non-randomness as well as smooth transition that is involved, and that smooth transition can be characterized by a membership function. Yes. So now what is membership function? It is a curve. For what purpose this curve? This curve is meant to define each point in the universe of course to a degree of values. So in the universe of course you have a lot of values, but for all the values I need to characterize the with a degree of value, and that degree of value is characterized by means of a membership function. See how, say for example, see this example, set of persons. I want to mention up to this, I want to make that person as a tall person. I have two ambiguous person here, so I am taking these two ambiguous person, I am putting it here, right. So by means of the height value, this person is treated as a tall because I want, if I apply the sharp decision, sharp edged membership function. So if your membership function again you choose as a sharp edged membership function, then there is no use of fuzzy logic. I have x and I have mu of x. What is mu of x? Mu of x is a membership function. If I choose my membership function as a sharp edged membership function, again there is no use. Again it is going to be a bivalent logic. But if I want to choose a gradual increase of function, see, definitely a tall person, really not very tall. So like these kind of values, if you ask whether he is a tall person, no, he may be a tall but he is not at all really a tall person. See how the words are coming up, totally the confusing, totally the words is uncertain and vague. So these uncertain words and vague words are classified. So here in this case both are tall person. He is a tall person with the 0.95 confidence and he is a tall person with the 0.3 as confidence. But here he is the only tall person but here he is not. So this kind of sharp decision is not allowed with respect to fuzzy set theory. So fuzzy sets describe vague concepts. Instead of saying runner, you may use the word fast runner. Instead of using weather, hot weather. Instead of using days, we are saying the weekend days. So a fuzzy set always admits the possibility of partial membership in it. For a value, you may not say the true degree into it, and it may also involve the partiality of other value, then fuzzy belongs to the great one, right. See, only for the 80% of people Friday is a weekend, but for others it is not so like that. So a fuzzy set is uniquely specified by its membership function. See, when you define a membership function and if you want to quantify the value from the membership function, you need to think about several important metric associated with the membership functions, or otherwise I can call by the name nomenclatures. What are those points? Core, crossover points, alpha cut, support. These are all the values associated with the nomenclatures of MF. Say for example, if your membership function is a bell shaped curve, right. If some values can pass in this region, some values can pass in this region, some values can pass in fall in this region, some values fall in this region. Accordingly, you may say the value. Those values fall in this region are called core value. Definitely, see, it is at the top, and it is a partial value, that is a crossover points, and these are all alpha cuts and support. So these are all the some nomenclatures of MF, and you wish to understand these kind of values with respect to the membership function: core points, crossover points, alpha cut and support. See, the support of a fuzzy set is defined as all points such that mu of x equal to 0. The core of a fuzzy set is mu of x equal to 1. Crossover points mu of x equal to 0.5. Alpha cut, it should be, the value should be greater than or equal to alpha. So these are the 4 kinds that you need to define with respect to understanding the membership function. Based on that only you have to decode the, or you have to quantify the value from the degrees of values. So support, core, crossover points, alpha cut. These are the some commonly used membership function: triangular membership function, trapezoidal membership function, bell shaped, half bell shaped, like that of membership function. Generalized bell MF, see, generalized bell MF, Gaussian, even Cobb trapezoidal. So some more membership function. For each membership function you have associated membership functional value. See, max min of this cut value A, B, C. See, the x is the degree value, A, B, C's are the cut points. Likewise, a trapezoidal, Gaussian, a G bell MF, like that, all values are there. These are all very much essential for continuous universe of discourse that we have seen in the previous lecture. So when you want to have a continuous universe of discourse, and that continuous universe of discourse is characterized by means of membership function, triangular, trapezoidal, and for each membership function it is associated with the mathematical model, and that mathematical model you should solve it in order to quantify the singular value to make decisions, specification. This is one of the most important tasks one has to follow for transforming a crisp set theory to a fuzzy set theory. So when you want to apply fuzzy to any data oriented or any idea or any linguistic based information, the first task is fuzzification. What is mean fuzzification task? Transforming a crisp value into a fuzzified value. Why I need to transform the crisp value into fuzzified value? Because to train the system, to train the computer, you need to convert that temperature or age, whatever may be the variable that are provided into the environment, those variable may be first converted into a linguistic variable. If it is temperature, my linguistic variable will be cold or warm. If it is age, my linguistic variable may be young or old, like that. So the first task is identification of linguistic variable. How a linguistic variable is characterized? A linguistic variable is characterized by 4 parameters, quintable. What are those 4 parameters? Actual value, that means actual name, and what are the terms that associated with that, and what is the universe of discourse, and what is G? It is a syntactic rule and followed by semantic rule. So it is characterized by 5 parameters: x, t of x, g and m. So what is G? It is a syntactic rule that generates the terms T of x. What is M? It is semantic rule which associates a membership function to each linguistic function. So let me take this idea with respect to one example. Say for example, my parameter is age. So what is x? It is age. What is the term set of x? Age I can treat as young, not young, very young, old, not very young, not very old, right? So I can linguist. What is the universe of discourse? 0 to 100. So you over the age I have included the word called young, middle aged, old. This is the primary terms. Over the primary terms I am using not, negation, very, more, less, quite, extreme, either, neither. These are the words, connectives, negation, gedges. See, negation, gedges, connectives. These are the words and these follows syntactic rule G, followed by semantic rule. What is semantic rule? What kind of function that can be associated with that, whether it can be a triangular function or trapezoidal function or Gaussian function. So this is a very much planned execution before applying the fuzzy set theory. So you need to identify a variable from the problem or from the environment that has been provided for developing a fuzzy idea, for which you need to give a name, for which you need to identify a term set, and then you should define the universe of discourse, followed by whether you can apply the negation, gedges, connectives over the primary terms. After that you should think about what membership function is suitable to quantify those values. So these are the two things that you need to remember, syntactic rule and semantic rule. Other three are very common in general, right? So then followed by identification of these kind of steps, then you need to partition, see up to this young, see 0 to 40 I can treat that young. Where the middle age comes? The middle age comes 20 to, yeah, yes, 70. Where the old comes? Old comes from 40 to 90, right? So if you could find that there is overlap, there is, so it means that for some person, young is up to 40, for some person young is only up to 30, right, because middle age starts from this 20. So this is the subjective phenomena and you need to quantify the subjective phenomena by means of membership grades. Membership grades. The membership grade is characterized by these membership functions. So this you should remember while you are doing it. Now comes the core topic, that means set operation. Before understanding the fuzzy set operation, because the fuzzy set and classical sets are one and the same, only the thing is the presence of membership function. In classical set there won't be any membership function, only the set value is there, whereas in membership fuzzy set you have a membership function and it is treated as mu of x. So what is set? A set is a unordered collection of well defined objects, right. So for each set you may have a description, you should have a roster and you should have a builder, right. So how you are making it? Say for example that set of days in a week. So set A is read as set of days in a week, right. So how we are defining in the set builder? X is nothing but x, A equal to x such that x is a day in a week, like what we have decided. So this is what you need to define a classical set. So with the three capital letters, three ways to indicate a set. One is a description, another one is roster, another one is set builder, that you think. The first one is used to describe, second one is used to list the elements, third one is a kind of a rule, how to notate it, So this is the way in which you can represent the classical set. In the same way you have to represent for fuzzy sets also, right. You also know, say for example set of all vowels in a, so v equal to set of all positive integers less than 10 can be expressed, set of all positive integers less than 100, see like this you can represent. So this is the general form and this is the notations, that means set builder. So the first thing is description, the second one is roster and the third this one is the, so this is the way you can study the sets and you may treat that as a elements of sets, right. This is classical set. And of course, to study further the classical set, you may have the Venn diagram also. You have the universe of discourse and the particular set theory. So this is Venn diagram is very useful technique for picturizing the relationship among the sets, right. So in universal set or the set which is part of the universal set, like that. You have one more set if you want, B, and you may treat that as a union and intersection, like that, and I'll see. If two sets are equal, A and B are two sets are equal, then that equality is in the universe of discourse. So what is this universe of discourse? Universe of discourse is a set of elements, and one set is having 135, another set is having 351. If you look at it, both are equal numbers, so set A is equal to set B, and this is the universal set and this is the unique set, right. Subset. For any set, you may treat this as, see, this is universe of discourse. Under this universe of discourse, you have a set B. Inside set B, you have a set A. So this is subset. So how it is read? A subset B. How it is notated? A subset B. It is notated like that, right. So pi, wherever you use, it is a null set, right. So this is the way you see, yeah, or set A is given, this is 2 3, set B is given 1 2 3 5. Now what is the relationship between set A and B? Since 2 and 3 is also present in B, now the set A is the subset of B. So also set A is a subset of C. But what about B and C? B and C, you can also say that, right. So in that way you need to represent the subset also. C is a subset of B, but B is not a subset of C, because B is having a more number of elements than C. We may say B is a universe of discourse also, right. And the operations are union operation, intersection operation. Given a universe of discourse, you have one set A and another set B. So the mid one is the intersection. And joining these two values A and B is going to be union. Union is represented as A union B, intersection is represented as A intersection B. This, see this upward, this is treated as union, and this is cap is treated as U is treated as union, this cap is treated as intersection, right. So this intersection will take only the common elements. See 1 2 3 4 union 1 4 5 6, writing all the elements put together, but you should ensure that there should not be any repetition. But when you take the case of this one, see intersection, what are the common elements? This 1 and 4 are common elements, so common elements alone has been displayed. This is the union and the intersection operation. Next operation is complement and disjoint operation. Complement. See, this is U, inside U I have a set A, so apart from set A, whatever the elements are there, all are negation, they are complement. Disjoint. We have two sets. If that two sets are within the universe of discourse and there is no common element, if you say, if I take intersection, the intersection is a null set. If there is no common element, then it is a disjoint set. See, universe of discourse is 1 2 3 4 5 6 7, and A you have 1 2 3 4. What is A negation? You should note down the element that are not available here and you need to record it. This is A negation, either A negation or A complement, like that you can represent. Why? When the two sets are treated, there is no common element. If there is no common element between this A and B, it is disjoint. So this is the idea. So what are the properties of crisp set? So when you go through probability and set theory, you may have lot of laws, identity laws, domination laws, idempotentation laws, commutative law for union, intersection. See, these are all many laws, and these are all the notations. These are notations. A union pi, A intersection union, A union, right? So there are so many laws are there. So up to this, what are this? Up to this, classical set operations, elements of sets, Venn diagram, set equality, subset, union and intersection, complement and disjoint, properties of crisp sets. So these are all the kind of idea that I wish to recollect from mathematical set theory. Same thing is applicable for fuzzy set operation also. The fundamental difference is the notation. So in classical set theory, I have represent A is the subset of B like this, whereas in Fuzzy set I have represented like this, mu A is the subset of mu P. This is fuzzy set theory. In classical set I can represent A bar, whereas here mu A bar, like that, like union also, right? This is union. I can use max, I can use min, I can use min, that is intersection, right? So this is the fuzzy set operation diagram. See, this is A is contained B, this is the two sets, this is the universal set or complement set, like that. See, A or B, A and B, negation not A, right? So this is the set operations by means of diagrams. This is A is contained A. See, you have A one set over which B. This is A and this is B, right? This is A, another, this is B. This is A, this is B. This is, right? This is A and this is universal of discourse. This value not A. This is like that. So like that. See, everything is common like that, right? So again this representation can be represented in this form also. This is A and it is reciprocal is not A, complement. This is A and B, this common portion is A intersection B, both the portions are A union B. I can represent like this also. See, diagrams and all, it is a mere representation only, and it portrays the proper meaning as well as the proper idea about the operation. See, again A union B, A intersection B and A complement B. So it is represented like this, mu A union B x, mu A union B B, mu A negation B, like that. So this is classical set theory and this is fuzzy theory. For fuzzy theory you have to take the min value, and for classical set theory I have to take the max value. Minimum of mu f x, mu b of x, max of, so this is more and more important with respect to minimum and maximum value. So this is the idea, we get that. So fuzzy set operations examples, right? So complement, how I can take, max I can take how, and min I have to take how. See, 1 minus A I have to take, see, consider two fuzzy subsets, right? See, set X referred as A and B. So what its corresponding cut set values, that is membership degree grade values for A, for B, for C, for D, everything is. So this is a kind of fuzzy set operations. So complement I can do like this, for max I can do like this. If I want to do union operations, then I can apply max operation, max of A comma B. For two sets, if I apply max operation, then it is going to be min union operation. For two sets, if you apply min operation, then it is going to be intersection operations. So this things you, where I have to apply max and where I have to apply min, this is most important. So for a set of elements that is given, you have A as well as you have B. So A is treated as this and B is treated as this. So I have to calculate the complement operations, union operations. Union operation is nothing but max. Say for example, A 1 bar A 0.6 A. So 1 bar A 0.6 A. So which is greater? 1 is greater. So 1 is brought here. 0.9 A, 0.9 B. So both are same. So accordingly you need to do the calculations. Again properties like that of classical set theory, here also properties: commutativity, associativity, distributivity, idempotency, identity, transitivity, involution, right? So here this symbol is there, this means that this is fuzzy set, this is set A and this is fuzzy set A. Over the A, if you put some cap, it is treated as fuzzy set. So if you do not put any cap over it, it is simply A. So what I wish to say to you is, the fuzzy set operations are the set of operations that are very similar to classical set operations. While you are studying the classical set operations, all the classical set operations are simply equal to mathematical operations, and that mathematical classical set operations will be only imitated to a set of fuzzy set operations. Under fuzzy set operations you have subset, complement, union, intersection, followed by fuzzy set properties like commutativity, associativity, distributivity, like that and all. So with this, the first topic with respect to fuzzy logic is completed. and we have discussed about fuzzy sets and its associated operations. See you in the next presentation.